Okay, we're going to start with, this is the intro. To measurement and movement. Intro to measurement and movement. So what I've done for you guys is I've done a template. This is what I'm pretty much already going to draw, and I'm going to want you guys to fill in the spots what I don't have. Right? Okay. So we're going to start with the idea of distance. So we have a starting spot and a final spot over here. We're going to call this A. We're going to call that B for right now. Okay, and the path that we are going to travel, okay, you could just go straight to A and B, but we didn't do that. Okay, we're taking Mr. Toad's Wild Ride, and we're going to take this path. Right, so it's kind of all over. Right? Now, if you follow that path, okay, and you took one of those wheelie things, right, that you could trace every foot that you're taking, that you roll on the ground and measure distance. Have you guys seen those? Okay. Then you would track how far you've actually gone along that path to get to that spot. That is what we call distance. Okay, and it has a particular definition. It has a couple of them. It's the total length traveled. Okay, it is also. This also occurs when the path that you travel matters. Okay. If it matters how you get from point A to point B, then you're traveling a distance. Follow me there? Yeah. Everyone good so far? Okay. Distance has a partner. And it is similar in concept, but it measures things similarly, but we have to pay attention to it in a different way. And its partner is called displacement. Okay, so we have all right, so we're going to have these same two spots again. We're going to have A. We're going to have B. All right. Now, the displacement then is just it's that. Okay. It is the straight line distance from one point to another. And the way we measure this one, okay, or so the idea here is this is the distance. Okay, it's the distance from one point to another without regard to the path. So it doesn't matter how you got from here to there. If this is here and that's there, and those are the two places you started and you finished, it's just a straight line path between them. Yeah? Okay, so think about it like this. Where are the seniors going to lunch these days when you guys go off campus? Where's the cool place to go? Home? That's decidedly less cool than what I was thinking. Let's say you head over here to Arsenio's, right? You guys know Arsenio's over here in the, okay. The distance you have to travel to get to Arsenio's is up Millbrook, over Shepherd, into the parking lot, right? But the displacement is really, it's just here and there, right? So as the crow flies, right? What? Okay. The displacement as the crow flies is a lot shorter, right? So we would have to drive up Millbrook or get out of the parking lot, get then up Millbrook and then across Shepherd and then into the parking lot. Arsenio's, where here, this is us now, this is Arsenio's, straight line, that's our displacement. Yeah? Okay. Can I go? Did I train any of you guys on this yet? Okay, I'll have to do that soon. Okay, we have a particular way of measuring this. Okay, and it is just measured as okay, it's the final position minus the initial position. Okay, and we're going to call these, so in this particular case, it would be, okay, so what was our final position here? Point B, right? So it'd be wherever B is, and then we would subtract A. But in general, we're going to give these different variables, and we're going to call any position, we're going to start calling it X. Okay, where this is our final position, we're going to call it XF for final, and this is going to be XI, and these are both subscripts. The F and the I are drawn like halfway below, a level halfway below the other letter. Have you guys seen that before? The subscript lettering? Okay. So in this particular case, our final position minus our initial position is going to be XF minus XI. Yeah? Okay, so, and we call this value delta X. And this delta, this little triangle, our triangle means means the change in, and it's the letter delta. Okay, so this delta, whenever we put in front of something, it means the change in whatever's coming after it. Okay, and the way we measure change is what our final value is minus what our initial value is. Yeah? Okay. This has very particular implications. Okay, these implications are well, let's go back for a second. I want to actually evaluate this. Let's say right here, we call that place 0. All right, we'll call this place over here then, we'll call this 6. All right, if this is 6, let's give a value for this guy over here. If this is at 6, and then we go to 0, and we go past, what do you think we could give a value for this? What's that? Negative what?
3.
Sure, negative 3. Sounds good. Okay, so our displacement, if we travel from A to B is going to be, so A to B is going to be 6, right? Minus, but what do we subtract from it? What's the final place? Is it just 3? No, it's negative 3. Okay, and if we have these two, if we subtract a negative, that really means it's a what? It's a positive, right? So this becomes a displacement of 9, right? 9 meters, 9 miles, 9 inches, whatever. Okay. But what if we started at B? In fact, what if up here we start at B? What would our distance be if we start at B and we do this all the way to A? Is distance going to be negative? No, you're going to travel a certain length, right? That's how far you went. What if we do it down here? What if we go from B to A? How's that going to affect here? If we go B to A, what would our final position be? Here's A, right? Here's A. What's our final position? Negative 3 is where we stop, right? So it's going to be negative 3. Okay, that's final position. And minus our initial position, well, that was 6, right? Well, negative 3 minus 6 equals... Sorry? Negative 3 minus 6 is negative 9. Yeah, I couldn't hear you guys. Yeah, is negative 9. Okay, so we've got a positive 9 and a negative 9. All we did was change direction, right? So what do you think that negative means? Right. And that in this case, our path is important, right? Okay, it matters. Did I write it? I didn't write there? Oh, no, I didn't write that. That the order that we're going in, the order matters. Yeah? That where we start from, where we finish, matters. If we start in one place and end in another, and then we switch them, okay, we're going to get a different value for our displacement, right? Okay. This is very, very important for us. Okay, so our implications here. Okay. That our displacement implies that there's a direction. Okay? That if we talk about displacement, it means that there has to be a direction that you're traveling from one place to somewhere else. And that can be negative. Okay. So, our conclusion here is that this negative, whenever we talk about a negative or a positive or negative, means the direction of the change. Yeah? Okay. If you go from 3 to 6, from negative 3 to 6, or from 6 to negative 3, what's the distance you traveled? If you travel along this path, but you go from 3 to 6, or if you go from 6 to 3, right, negative 3 to 6, or 6 to negative 3, how far did you travel? 9, right? And 9 is going to be the same either direction. But if you establish where you start and where you finish, your displacement could either be +9 or -9 based on where you're starting and where you're finishing. You follow? We follow there? Okay. Good. That brings us to 2. Which is speed, or speed and velocity. Okay, so from what we already talked about so far, what do you think speed is? How fast an object moves? Yeah, well, in fact, that is really it. But how can we measure that? Think about what we just covered. What's that? Well, it's all in there somewhere.
How fast you get to A to B.
How fast you get from A to B? How do you measure that? You're on the right track. How do you measure that?
Time.
Using what?
Time.
Using time. Okay, so now we've got this new factor involved. Yeah? Okay, so you guys have an intuitive knowledge of this. If it takes less time to go somewhere, for two things, if you start here and finish here, and one thing takes less time to accomplish that, it's going faster, right? We have this idea of it. In fact, we use speed. We have common ideas of speed when we talk about miles per hour, right? It's a certain distance for every unit of time, right? In fact, that is our basic idea of speed, is distance divided by time. That's how we measure it. Yeah. We're going to draw our. You guys have that path on there, right? Already? Okay. So we're here, and what path did you guys get? What did I give you? Right. Okay. So it's. Okay, and we've got clocks. So that's what these circles are. They're going to be clocks. All right, and we're going to give these different times. We're going to call this at 1 and 2 and 3 and took a while to get to them, so that's going to be 5 and right, and we'll make this one 7. Okay. So our speed then is, it took 6 units of time, right, to get, we'll call them seconds, right? It took us from 1, we started at 1, and we finished at 7, yeah? Okay, so it took us 6 seconds to get through this whole path. Follow me there? Mm-hmm. Okay, and the whole distance we traveled, okay, so we have this total distance. So we'll define speed here. Speed is our, is the total distance it's the total distance traveled per unit time. Okay, and speed in particular, we'll call it d for distance over our change in time. And that's going to give us our speed. Because in science, we don't use English measurements anymore. We use metrics. This is normally measured as meters per second. All right. So this is our speed. But it's something to keep in mind, but it's usually not very valuable to us. What we really start to use more and more of and pay attention to is what's called velocity. And this is where we need to start breaking your mind here. You have probably been growing up and when we talk about things and developing our language that speed and velocity are interchangeable terms. If something's moving at high velocity, it's moving at a high speed. And that's generally true. But in physics, we have to distinguish between the two. Because just as with displacement and distance, we have two different concepts, right? One is total length traveled, one is from point to point. Speed and velocity are the timed versions of distance and displacement. Okay, so velocity isn't the total distance traveled in that amount of time. Velocity is our displacement divided by our amount of time. You follow that? Okay, so to get from here to, in fact, this even doubles back a little bit, doesn't it? You get to here and then back a little bit and then over when he's traveling, if we're just talking about the displacement. Yeah? Okay, so this length of time, like say from here to here, kind of goes really slow, right? All right, so our velocity is okay, and we write it with a little bar over it to show that it's got a direction. It's a V, sorry. I'll rewrite it. Okay, that our equals our final position minus our initial position divided by the time it is that we finished minus the time it was when we started. Yeah? So these two go together, and these two go together. So you have at what time did you start, and at what time did you finish? And then you subtract your distances, you subtract your positions, and you subtract your times, and this becomes your velocity. Now, because we have these subtractions in here, we can again have a positive or negative thing. And so positive or negative, again, positive or negative implies the direction of the change of the position. Okay. I want to give velocity specific. Did I give you guys? I did not. I want to give you guys a specific definition. It is the rate of change of position. All right. Which brings us to the third one, and the granddaddy of them all. And this one is acceleration. All right. Acceleration. This one I kind of have to define because it's difficult to explain straight out, but or explain with pictures. So, acceleration is the rate of change of. It's the rate of the change of the velocity. So it's how this value changes over time. Okay, or it's how quickly you're getting faster, or how quickly you're getting slower. It's your change in how fast you're going.
So it's getting as fast as you can in the slowest or in the fastest time.
I'm sorry?
You're basically speeding up as fast as you can in the fastest time.
If you want to increase your acceleration, the most acceleration means you're speeding up as fast as you can in a shorter amount of time. Yeah. Okay. Our acceleration is given by A, and it's got a bar over it because it's got a direction to it, equals our velocity okay, so it equals our delta V over delta T, or a change in velocity over a change in time, and we define our change in by final minus the initial, right? Okay, now you guys have this picture. I don't want to draw my figures again. Acceleration is something you can feel.
You go back.
Okay. Acceleration is something you can feel. Okay, so imagine you're in your car and you hit the gas pedal. Do you guys know what the real name of the gas pedal is? So what? It's the accelerator. There's a reason for that. Because when you step on the gas pedal harder, you accelerate. What does it feel like when you step on the gas pedal? What do you feel in your body? Okay. What's that? Yeah, it throws you back, right? It pushes you into the back of the seat. Okay, here's what really happens. You feel like you're getting thrown back, but what's really happening is that the car
Moving forward.
is pushing into you. And so your acceleration is that way. And so you feel the seat pushing into you. Your body, and we're going to talk about inertia tomorrow, your body doesn't want to go anywhere. That's one of the things about having mass, is that things that have mass don't like to change their motion. So when you're in a car, and you're sitting in the car, and the car accelerates you, you feel like you're getting pushed back, but it's really the car pushing into you and making you go faster. Okay, so what you feel is, you actually feel this. Okay, it feels like that, but this is what's actually happening. So if you step on the brake, okay, the brake is the negative accelerator. It makes you decrease your velocity. Yeah? You slow down whenever you use the brake. So your body's going to go forward. Okay, it feels like that, but what the car is actually doing is accelerating that way when you step on the brake. You guys follow me there? Okay. So we'll get more into acceleration more and more later on in the unit. I do want to show you guys this down here, though. This is how we move in 3 dimensions, and so I want you guys to establish this in your head. imagine this is a sheet of paper. Imagine a sheet of paper in this. Have you guys seen three-dimensional axes before? You guys seen this before? Okay. We're going to draw a sheet of paper on here. A sheet of paper. This sheet of paper is sitting flat on the desk. You guys see that? Okay. It's sitting in what we call the XY plane. Yeah? Alright, so this is towards you, that's away from you, that's to the right, that's to the left. Yeah? So you can imagine moving your paper like this. So if that sheet of paper is this sheet of paper here, so we've got, this is going to be away from you, towards you, right, and left. Yeah? Okay. In this class, we make these directions have certain, one's positive, one's negative. To the right is positive, to the left is negative, just like a number line. Okay. Forward is positive, backward, so this way in the y-axis and this way is negative, right? Okay. And then up is positive, and down is negative. Yeah? Okay, so to you guys, just to make sure we got this, that's positive. Yeah?
Yeah.
Okay. That's positive. And that's positive if you're facing forward. Does that make sense to you guys?
Yeah.
Okay, so the other ones, negative, negative, and negative. So we're establishing that in class because we're going to have different, you know, if things going up, it's going to be positive. If it's going down, it's moving in the negative direction. I want us all on the same page when we're discussing that. Okay?
What if we're facing in different directions?
That's a good question. You pick one.
Okay.
Because let's say you're facing, actually a really good question. Okay, this is us, right? And let's say we move in that direction, right? Well, let's say you're at 0 and I'm at 2, and we keep the same distance apart, right? And we move this way, so you're at 3, and then I would be at 5, yeah? Right? We both will have moved right? So it would be negative to me. Okay. No, I take we choose one of them, and we stick with it.
Okay.
So it doesn't really matter which one because the math all works out if you stay consistent about which one you're taking.
Okay.
Okay. Okay. So that is it for today.